Okay. Matrix has a set of values in it. It's made up of rows and columns. Okay? Now, row 1 is at the top left, and column 1 is at the top left. So, this entry, let's say it's A, I don't know what it is. Remember, when we don't know something, we give it a variable. It's going to be a value. This is going to be in row 1, column 1. Now, you're not going to actually repeat explaining this. I'm explaining it so that when we do some calculations, you'll understand which position I'm talking about. You need to memorize basically what it is that makes up a matrix. Okay, so what is this position right next to it then? We'll say B.
Row 1, column 2.
It's going to be row 1, column 2. That's just that position.
I don't get it.
Row 1. This is row 1. Right?
It's like a grid.
This is column 1. This is column 2.
What's up with the A11 and the 11?
That's not 11. That's row 1, column 1. Row 1, column 2. Alright, making progress. Okay? So, let's say we're over here. This is entry C. Sophie, what is that position?
Row 2, column 3.
Alright. And this goes over infinitely many times. This goes down infinitely many. And we'll call this row M because we don't know how many rows there are. We'll call this column N. Oops. We'll just say Z here. This is M, N. Okay? We don't know how many rows. We don't know how many columns. Everybody got that? How to find your position in a matrix. Anybody not understand?
Why you turn to Z?
I didn't want to use R and C. Okay, so this would be called an M by N matrix, meaning how many rows there are by how many columns there are. You'll get this here in a second when I give you an
Why
example.
don't you just name it R and C instead of M and N?
We don't know how many rows there are. If I say R, which row are you talking about? So I use M because this last row is row M. This last column is column N.
Oh, okay.
Got it?
I'm not sure.
All right, it all makes sense. Let's look at an actual problem. Okay? So let's do this. This is example 1. Don't worry, it's actually really easy what you're doing today. I'm just trying to give you a little background on positions, and when I say, row 2, column 3, I want you to know which number I'm talking about. Okay? All right. So we're going to do. I'll just write it down, and then I'm going to ask you some questions. Example 1. I wrote that a little too big, but we'll go with this right now. We copy that down. I have some questions for you. Sophie, what is in row 2, column 2 position? -1, that is correct. Okay? Sam, row 1, column 3. Yes. Row 1, column 3. That's 3. Got it? Min, what size is this matrix? What size is that matrix?
What size?
Yeah. Rows by columns.
3 by 2. 2 by 3.
Yeah. 2 rows by 3 columns. So this is a 2 by 3. You will have, if you when you go to college, if you have to take a linear algebra class, you will spend half a semester working with matrices and doing lots of weird calculations. you don't need to know this, but I'm just going to tell you what it is that this all means. This here is actually an equation. This is 1x plus 2y equals 3. This is 4x minus 1y equals 0. And what you do is you deal with multiple equations for situations in businesses, and you are able to put multiple things together and solve production problems that businesses have. This is a very important skill to have. If you are good at something like this, you can become an actuary and really help a business out and get a great job making great money. And it's really quite simple how to do this stuff. So right now we're just doing baby steps. That doesn't mean anything to you yet. Algebra 2 you'll do a little bit more. Okay? So right now we're just learning positions and what calculations we can do with them on a basic level. So let's add another matrix to it.
Okay.
I'm going to write this a little bit smaller so we have a little more room. This is also going to be a 2 by 3. You cannot add or subtract different size matrices. They must be exactly the same. Do you understand?
Yes.
Yes, sir.
Excellent. Because if they try to get you to do that, don't. And say you can't. And that would be your answer. Alright, so this one, this is 0, negative 1, negative 3, negative 2, negative 1, 4. That will give me another matrix, and that answer will also be a 2 by 3. Guess what you're going to do? Somebody explain the best they can what you think you should do. Ready? What do you think we're going to do?
Like add the columns, like row 1, column 1, row 1, column 1.
Yeah, the exact same entries get added together. Row 1, column 1 better be added to row 1, column 1. So 1 plus 0 is 1, and so on and so forth. Everybody figure the rest of it out. Anybody lost? Okay? Now, to get this row 1, column 2, you need to add row 1, column 2 with row 1, column 2. So 2 plus negative 1 gives me 1. To get row 1, column 3, add row 1, column 3 with row 1, column 3. 3 plus negative 3 is 0. You guys do the rest? Anybody else still lost? Okay, so the answer, what did you get? 2, negative 2, and 4 on the bottom?
Yes.
Alright, isn't that simple? They must be the exact same size. That doesn't mean 2 by 3. That means if it's a 1 by 2, you better be adding or subtracting a 1 by 2.
Multiply by 2.
Okay, today we are not going to multiply matrices together. We are going to multiply.
It's not today.
It's called multiplying by a scalar. So, example 2. 4 times this matrix. First of all, what size matrix is that?
2, 2.
2 by 2? Good. What do you think we're going to do with the 4? This is called a scalar, by the way, for vocabulary reasons. Josh?
Multiply it by everything.
Multiply each entry by what's on the outside. So you will get 8, 4, negative 12, and 8. And that is a 2 by 2 as well. Okay? Who is golden? Who knows everything? Who knows all of this? What we just did. Who would like to see another example of this one? Alright? Example 3, and then I'll turn you loose. Negative 2 times 0, negative 1, negative 3, 4, 1, and negative 2. Everybody do that. Those those of you who are struggling, take this -2 times each of these entries. What size matrix is it? 2 rows by 3 columns. So your answer should be 2 rows by 3 columns.
Zero, 2, 6, top row.
-2 times 0 is 0, yes. -2 times -1 is +2. -2 times -3 is +6. Is that what you said? We got the first row correct. Okay? Who's bored out of their mind? How you doing? What'd you get for the second row? Well, can you do it? You can just tell me. You don't have to say it.
Why are you talking?
I'm talking to you.
Julia's talking.
He thought you were talking to him, he started answering the problem.
Well, they thought I was talking to them. They said, who are you talking to? So I pointed to her while I was talking to them. Okay, go ahead. Yeah, -2 times 4 is -8. -2 times 1 is negative. Good. -2 times -4 is +4. Who got that right? All right, now who's golden? Who's ready to go? Who's ready to get at it? Awesome, you're Simon.
Oh, I need a piece of paper. There you go. Don't you have a spiral notebook?
Page 95. 1 to 13.
Yeah.
Don't forget to turn your power.